Ali Goldrat discusses this chart in his 2006 article, Standing on the Shoulders of Giants, which, if you haven't read yet, I strongly recommend you do. First of all, let's understand the axes. The y-axis is simple. This indicates the amount of management attention required to get anything completed in the plant, which obviously increases as you move vertically up the axis. The x-axis is a little more difficult to understand. You will recall from the previous video the definition of buffer that I used on several occasions was a liberal estimate of the time required for inventory to move from one point in the plant to another, such as, for example, from raw material release to the drum. By time buffer size, Goldrat is indicating the increasing amount of time that inventory is in the plant as you move horizontally along the x-axis. It is, of course, essential to remember that the inventory is in the plant because the plant management allowed it to be in the plant, which is the crux of the matter. The bathtub-shaped curve on the chart is essentially telling us three things. Firstly, conventionally managed manufacturing plants tend to find themselves on the upper part of the right side of the curve. You can see the red chalky X on the chart. Conventionally managed plants target efficiencies, or in other words, high utilization of machines and people, and release additional raw materials to keep people and machines busy. They try to force their customers to order in minimum order quantities and manufacture in economic order quantities, and they try to save on setups, delaying work orders that should flow naturally through the plant. These behaviors together create a high inventory environment characterized by numerous large queues, long manufacturing lead times, poor due date performance, and many other negative side effects that we listed in previous videos. And, if we're honest, widespread and ongoing chaos in the plant. In fact, in many plants like this, firefighting has almost become an official career path. Secondly, the chart is telling us that very low inventory plants also require considerable management time and attention to complete work orders. But this time the cause is too little time for the work orders to successfully make it through the plant. When the time allowed for inventory to move from raw materials to shipping is very short, the plant becomes highly susceptible to shortages of material, machine breakdowns, operator absence, processing out of sequence, and many of the other problems that are facts of life in manufacturing environments. A plant like this also requires constant and ongoing management attention to correct the inevitable deviations to the plan. Manufacturing lead times may be short, but only in the rare occurrences when multiple independent variables are temporarily aligned, or in other words, once in a blue moon. Being on either the left or right side of the curve is a recipe for chaos. But the good news is that between the two sides of the curve is a large plateau where inventories can be relatively low compared with the right side of the curve and requires little management intervention relative to the left side of the curve. The first objective in an SDBR implementation is to move the plant away from the right-hand side of the curve and into the plateau. Why do I say the right side of the curve? Remember, one of the conditions that we assume for SDBR to be successful is that the ratio of touch time to elapsed time is at least 1 to 10. Before implementing SDBR, it is wise to check this, which is a relatively simple task and can often be done from the peace and quiet of the production manager's office, providing he has access to the plant's MRP software. So, how do we move from the chaos of the right side of the curve to the relative tranquility of the plateau? Let's find out.